Okay, so we'll begin our class with BJT Part 1. So we haven't finished in the last class for Part 1. Okay, so in the last class, we actually have done on the basic operation of BJT and IV characteristic. Okay, there are three common or three configuration of BJT. Okay, so it has so BJT itself has three terminals. It has base. Okay, it has collector and it has emitter. All right. So this is how it looks like for the BJT. So I think you have okay. So this is your BJT. Okay, it has two types, PNP and NPN, but it has three terminal. Okay, C is collector, B is base, E is emitter. Okay, for this case, arrow is pointing out, so this one is NPN type. Okay, NPN type. All right. Since it has three terminal, okay, collector base emitter, so it has three type of configuration, which is common emitter, common collector, and common base. Okay, the one that covered in your syllabus is common emitter. So what does it means by common emitter? Means that the emitter here, okay, is connected to the ground. Okay, no matter that emitter has resistor or not, that emitter will be grounded. Okay, that it means by the common emitter. CE is common emitter. All right. So I have also explained on the transistor mode of operation and its application. It has mode of operation of active, okay, forward active, okay, and then it has saturation, and then it has cut off. Okay, so for both for active forward, okay, active forward, usually the application is for amplifier, where BJT it is used as an amplifier. Okay, for saturation and cut off, it is used as a switch. Okay, for saturation, when the current is high, so the switch is on. Okay, for the cut off is the current is very very low, means zero, that is during the your transistor or the switch is off. Okay, so today we will continue on the BJT part 1, introduction to the basic amplifier circuits, parameter, AVOC, AVAI, ZI, and Z out in decibel. Okay, so this is actually the parameter for your BJT, where AV is this is the voltage gain. Okay, so the gain, since that one of the application for transistor is amplifier, to amplify the signal, where you have, for example, an input, a low input signal, and you want to amplify your signal, increase or amplify your signal, you might have to use a BJT where it has gain value. Okay, to gain, to get the output, to get the output being amplified. Okay, so there are important parameter here, which is gain. Okay, gain. Okay, so this is AVOC, and AV is a voltage gain. Okay, AI is the current gain. Okay, and then Z in is the total input impedance. Okay, impedance means resistance. Okay, in the input of your BJT, you might have a lot of resistor involved, so the total resistor, we call it as a input impedance. All right, so Z out is the output impedance. Okay, so these are the parameter that you need to know, okay, in BJT. So however, these all gain parameters, okay, will be used in AC analysis circuit. Okay, for this part, okay, BJT, you're going to learn on the DC analysis circuit and also AC analysis circuit. So this parameter for gain will be used later when we enter the topic BJT part 3 for AC analysis. All right. Okay, so we have done a lot here on the introduction and also for the theory part of the BJT. Okay, okay. Now we will continue. So this is the mode of operation. Like I said, each type of mode operation has its own application. So it is applied to what type? It is applied to what? Okay, what application. So for active forward, it will be used as the BJT is used an amplifier. So for saturation and cut off, it will be used as a switch. Okay, switch. So there you go. This is the theory part. All right. So I also introduced you some of important equation related in BJT. So this one you have to understand. So it has three terminal. Therefore, it has three types of current. Okay. You have collector current represents IC, you have emitter current represent as IE, and also you have base current represent as IB. So IB is very, very small because it is lightly doped. Okay, base is usually lightly doped in BJT. Therefore, it has a very low concentration. And we expect that when it has a low concentration, therefore the current produced also very, very low. Therefore, sometimes, okay, sometimes that base current we ignore, and usually base current in the scale of microampere. Okay, so output current is the collector current and emitter current. So that one can be assumed as alpha equal to IC over IE. And when we do the derivation, alpha is approximately equal to 1. Therefore, we may assume that alpha IC is approximately equal to the IE. Okay, beta is a beta gain, okay, gain value, where in every transistor BJT, it has in the specification sheet, it has beta value. So it depends. So usually beta value will be given. Okay, beta value is the gain value where it amplify the input signal of your BJT. Okay, other than that, you need to know this formula. So IE is equal to beta plus 1 IB. Okay. For the transistor configuration, we have done this. All right, so let's begin what we should continue for today, right? So for the part B, introduction on the basic amplifier circuit. So these are the parameters. So this is quite simple, okay? So the introduction to basic amplifier circuit parameter. So we have this, okay? And the mid frequency AC. So this one will be using in the AC analysis, okay? AC analysis, okay? But we only cover the common emitter. Okay, so this is how it looks like, the basic voltage amplifier model. So this is your BJT. Okay, so this is your BJT. Okay, you have base, collector, and emitter. And this part is actually can be, in AC analysis, it can be converted into hybrid, a model, okay, model. Okay, this can be converted into a model. Okay, so when we convert it into model, so we will get this kind of circuit where it has input. So this is the input part. Okay, so this is the output part. So the input part of the circuit. So this one, okay, this at the center here where we represent in AC circuit, okay, it will be represented as this one. Okay, inside it, we call it as a amplifier model. Okay, in this amplifier model, it has Z-in, which is input impedance, and also this one AVOC is voltage gain at open circuit V in, and also Z out. So for this kind of ideal voltage amplifier may describe this following characteristic. So it has infinite input impedance, zero output impedance, infinite voltage gain, infinite bandwidth, zero output offset voltage, and there is no drift in this parameter when a change in temperature occur. So let's take a look what it looks like. Okay, so this is how it looks. Okay. So like I said, this is your BJT. This is the input part of your circuit. This is the output part of your circuit. So there will be a lot of resistor connected to your BJT. So however, when we convert it into a amplifier model, it looks like this. Okay. So for example here, okay, so you have this one, the amplifier model. And this is your AVOCV in, this is your Z out. All right, so this is your V in. Okay, from this node to the ground, this is your input node. Okay, from this node to the ground, this is your V out. Okay, so how you calculate V in and V out? Okay, of course, we know that okay, so gain, okay, I think you all know gain usually. A represent as A is equal to gain is a value where you divide your output value to the input value. Okay, no matter what parameter. Okay, it can be your voltage. Okay, for example here V out over V in. Okay, so this one will be represent as AV, means that the voltage gain. Okay, it could be also represent your current I out over I in. So this one will be represent as AI, okay, which is current gain. All right. So from this formula, okay, from this formula, you know that if AV, which is the gain, is given. Okay, if you rearrange this formula, you will get that V out is equal to gain times V in value. So I believe you all know, rearrange this formula. Okay, so whenever AVOC V in, therefore this one AVOC means that this one, this formula AVOC is equal to V out over V in. This is the same thing, okay? The same thing, okay? So for this case, okay, V in is equal to the Vs. Why? Because there is no RS resistor here. Okay, there is no RS resistor. It's like a short circuit here. Therefore, it is in the same node here. We can say that V in is equal to the Vs. But if let's say we have RS over there, so you might need to do the KVL in order to get the V in. All right. So other than that, okay, the amplifier input voltage V in will be less than Vs, okay, because of the division between Rs and Z in. So this is what I meant when it has Z in, okay. Sorry, when it has Rs, therefore V in now, okay, V in now is no longer equal to the Vs, okay. For this case, you don't have Rs, okay, and it is in parallel. Therefore, V in is equal to the Vs. However, when you have Rs in your circuit, then you have to consider, you cannot say that V in equal to the Vs. So how you can get the V in, okay, from this circuit, as you can see, so this is your V in. Okay, let's take out this circuit like this. So across this V in is actually your Z in. So V in is actually voltage across Z in. Okay, do you agree with me? Because it is in the same parallel node. Okay, therefore V in is actually voltage across your Z in. Okay, in order to get your V in, okay, I believe that you all know already, we can use voltage divider rule. Okay, voltage divider rule. Okay, to get your V in. Therefore, V in here is equal to the voltage across that part is Z in. Okay, over Z in plus RS times Vs. So this is how you get your V in. Okay, when there is RS, therefore you need to do voltage divider rules in order to get your V in. Okay, but when there is no RS, therefore you can straight away say that your V in is equal to the Vs. All right. That's how you do it. So this is the same thing what I explained here. Okay. So V out in this case is equal to the AVOC V in. Okay, I believe that you all know. Okay, but from here, okay, from the calculation here, so from the equation, from the given itself, AVOC is actually so this part is AVOC times V in. Now you already have your V in. Okay, here in terms of Z in and Vs. Okay, if you plug in the equation, so this part V in, okay, is equal to this portion. Okay, therefore V out is equal to AVOC times all this part Z in over RS plus Z in over over RS plus Z in times Vs. Okay, so you get that portion. Therefore, from here, you will get another parameter. If I take out this Vs to down, therefore V out over Vs, okay, will actually equal to this portion only. Okay, so the AVOC times Z in over RS over Z in. Okay, that's it. That is how they came out with this equation. Okay, from here. Okay, therefore, so this part which is VR over VS, now we call it as a sorry. So now we call this part as voltage gain at voltage gain referring to the source, AVS. So AVS equal to V out over VS equal to AVOC times Z in over RS plus Z in. Okay, so that's how they derive all the box equation here. Okay, I hope that all of you clear. Okay, this part. Okay, because later we will be using this concept in the next part. Okay. All right. So from here, so now we are actually deriving for the input part. Okay, for the input part. Okay. Do you have any question before I proceed to the output part? No question.
The
No question.
ABS or
Mm-hmm.
B output over BS, right?
Yeah.
Previous
Again, explain again.
slide,
Oh, okay, okay. All right, okay.
previous slide.
Oh, slow. Okay. I explain again.
Then,
Okay.
then
All right.
the V
Mm-hmm. Hello? You're breaking up. Hello? Is it me or you? Can you all hear me?
yes, yes,
Uh-huh.
yes.
One more time. Just now, what's your question? When Chuan? When Chuan?
No, the ABS equal to B output over BS, right?
Yes,
Then
correct.
also equal to AB OC plus R Z1 over
Uh-huh.
ZI, right?
Yeah, yeah,
Because it's over.
yeah.
So it's
And then?
my
Oh,
the
it's actually
BS.
rearranging. No, no. This is actually rearranging the formula only. Okay, so I think let me show you one thing here. So let me explain again. Okay, so this is your circuit. So for sorry. Okay, so this is your circuit. So let me explain again, Yun Chuan. I think it's okay, doesn't matter. So this is your RS. So this is your Z in. Okay. Can you all see my drawing over there? Hello?
Can.
All right. Okay. So this is oh no, V out, sorry. So V out here. So V out here is equal to the AVOC V in. Okay, and then what else they have? VS and V in. Okay, VS and V in. All right. So let me explain one more time here. Okay, so how do we get V in? So in here, okay, as you all can see, so V in here is equal to the voltage across Z in. Okay, so we might want to use the concept of voltage divider. Okay, I think that all of you have familiar with this. Okay, so voltage divider. So in order to get V in, okay, V in is equal to Z in. Okay, over Z in plus RS, okay, times VS. So this part, I think all of you clear, right? So V in is equal to Z in
Yes.
over Z in plus RS. Okay, I think all of you clear about this part. All right, now, so they give that, okay, this one, okay, this one, where V out is equal to the AVOC, okay, times V in, okay, this part. All right. So from here, you know, we have calculated, we have derived the V in is equal to this portion, Z in over Z in plus RS something, okay. So we write again here. So therefore, we replace the V in, okay, this part equals to Z in over Z in plus RS VS. Okay, so this part. Okay, so when we simplify here, we will it's like rearranging, means that we are getting another type of gain. So now you only know type of gain AV, which is V out over V in. Okay, like I said just now. So you also know that AVOC also V out over V in. Now we have another parameter which is V out over Vs. Why V out over Vs? Vs also input now. Okay, this is not the same as V out over V in. Now the gain is now referring to this Vs. To this Vs. Okay, previously this AV is referring to V out over this V in. Okay, this V in. Okay, now it is referring to this Vs. Therefore, V out over Vs, okay, is equal to, so you take this V out to the down, okay, here, and you will get AVOC Z in over Z in plus RS. Okay, that's how you get it. Okay, so this part actually, so it has a new name now. Okay, it is, we call it as a AVS, means that voltage gain referring to the source. Okay, referring to the source. Okay, means V out over Vs, not V out over V in. Wen Chuan, are you clear? Hello? Am I answering your question? Is it
Yes,
your
yes.
question? Was it your question?
Uh,
Are you clear? I mean, not only Wen Chuan, how about the
yeah,
others? Also, do you
yeah.
clear? All
Yes.
right, great, great. Okay, how about, great. Okay, how about others? Okay,
Clear, clear.
Okay, very clear. Good. Okay, so good that when Chuan asked, because this part is important lah. Later we will use this lah. It's about the manipulating the equation. Okay, so this is for the input part. Okay, for the input part. Okay, so other than that, you can also have this. Okay, V in over Vs. Okay, sometimes they will ask you what is V in over Vs. So it is actually Z in over Z in plus Rs. Okay. All right. So this part settled. This is for the input part. Okay. Now we have output part pula. Okay. Output part. Okay. So for the output part now, here we are solving this input part. Okay. This input part. Now the output part. Okay. So for this case, okay, I think I need one more slide here. All right, so this one, now we are solving the output part here. Okay, so the circuit now has AVOCV in, and then it has Z out, and then it has RL. Okay, we know that V out, okay, V out, again, they are using the same rule, which is voltage divider rule. Okay, it's okay. Let me draw again. Just have to wait for me. Uh, So you have Z out here, and then you have RL here, okay, and then you have V out. All right, so now, so how can you get V out? Okay, so the same concept, you here in BJT or AC analysis of BJT, whenever you have this kind of circuit, there's only one thing you can do, which is voltage divider. Okay, so you apply voltage divider here. Okay, you will get your V out is equal to RL over Z out plus RL times the voltage here. Okay, voltage here, the source voltage here is given by AVOC V in. Okay, AVOC usually given lah. This is a gain factor which is given. Therefore, you can rearrange this part. Okay, take out the V in here. Why? Because your objective, you want to get your AV. Okay, AV. So you know that AV is equal to V out over V in. So the question just said find AV. So you need to think on your own. Okay, so AV is V out over V in. So what can you do to get V out over V in? So you have to manipulate the equation. Okay, you have to analyze the output part here. So how about you rearrange the formula, not the formula, the equation for the voltage divider, and you see there is V out and also V in. So you take out V out over V in, so it will leave with your RL over Z out plus RL times AVOC. Usually AVOC is the factor, gain factor value, which is will be given. So here you will get another parameter, which is AV equal to V out over V in. Okay. For the case of this one, they will ask you, find AVS. So you have to think yourself. Okay, how do I get AVS? So Dr. Izala said AVS equal to V out over VS. So how do I get V out over VS? So you rearrange the equation there until you get V out over VS. All right. So that's how you do it. Okay. So this is the parameter V out. Okay. AV is equal to V out over V in, equal to RL over Z out plus RL AVOC, which is I have derived here the same thing. Okay. And then there is also another Okay, what can I say? Another, they said like this. Okay, so how you derive AVS also. So we know that AVS. Okay, AVS. Now you have V out over V in. Okay, you have V out over V in. Okay, which is your AV just now. Okay, you wanted to get your AVS. So you know, if you put this V in over VS, okay, V in over VS, all right. So you will get something like this. So it is actually equals to the V out over VS. Why you are actually cancelling out this V in? So this, okay, so this equation, it is actually equal to VR, AVS, okay? AVS means you cancel out V in, you get V out over VS, okay? So finally, it is V out over VS. So now from here, you know that, okay, V out over V in is your AV, AV. All right. So times V in over VS. Okay, V in over VS, where can you get this V in over VS? Okay, from your derivation here just now, you know that your V in, okay, V in is equal to Z in over Z in plus RS times VS. Okay, so now I said you have to think logically or by using your thinking, how can you manipulate the equation? So V in over Vs is actually, if you take this Vs, go down, you will get that V in over Vs equal to Z in over Z in plus Rs. So actually, this part is equal to V in over Vs is equal to AV times Z in over Z in plus RS. Okay, so there are many solutions that you can do in order to get your AVS. Okay, it's either you find AV first, okay, you find AV first like this, okay, and then you rearrange the input equation here until you get V in over VS. Okay, AVS, or you can straight away find like this. Okay, like this. Okay, this is for the case of when there is no RL. When there is no RL, you can straight away use like this kind of derivation. But when there is RL involved, they will be different. Okay, they will be different. Means that you have to apply voltage divider at both input and output. Okay, in getting your AVS. All right, let's take a look on the example so that you all will be much clearer. Okay. Okay, before I proceed, do you have any question on this? No question? Okay. All right. So just now is voltage gain. Okay, now we have current gain. Okay, same that current gain is I out over I in. Okay, I out over I in. Is that current gain is equal to I out over I in. So it is the same thing. You manipulating the equation. So now it is transforming the input. Just now voltage Vs and Rs. Now you change to voltage to voltage to current transformation. So instead of in series, you will get in parallel. Okay, current source and also your Rs. Okay, from here, you can also apply current divider rule. Okay, the same thing, but you have to convert it into current source. Okay, instead of voltage source, okay, you convert this part to current source. Okay, you will get this kind of circuit, okay, in parallel. And then if you apply current divider rule, so you will get that I in is equal to Rs over Rs plus Z in time Is. So this one. Okay, for the I out, so how they get the I out here is actually from the KVL. Okay, from KVL. So this is from current divider rule. Okay, CDR is current divider rule. Okay, this one it is actually KVL at output loop. Okay, KVL at output loop. Okay, so they apply like this. So you have V out minus I out Z out plus it is actually I out equal to AVOC V in over Z out plus RL. Okay, I believe you all know this one. So V in equal to I in Z in. So they rearrange the equation. Okay, again the same thing. Okay, so you know that I out is equal to AVOC Z out plus RL. Okay, and V in here, they replace with I in Z in, I in Z in. Okay, remember your objective is to get this. Okay, I in, sorry, your objective is to get current gain equal to I out over I in. Okay, this one. All right. And you rearrange the equation. Okay. So this part AVOC over Z out plus RL. And this part is actually your V in, which is replaced by this portion. And you take out, take this I in, go down. Okay. So I out over I in is actually equal to the current gain equals to this portion. Z in over Z out plus RL AVOC. So these are all the formulas. And if you want to get AIS, so the same derivation like I have explained here. Okay, same derivation like I have explained here. So I out over I in. Okay, I in over IS. It's like you cancel out this part. Cancel out this part. You are actually get the I out over IS. Okay, it's like you cancel out, but you not cancel it out. Okay, it is equals to I out over I in, and now it is equal to I out over I in. You already have the equation here, which is Z in over Z out plus RL times AVOC. Now, what is I in over IS? Okay, I in over IS is from the current divider rule here, from here. So I in over IS is equal to this portion, RS over RS plus Z in. Okay, so this part. So you will get your AIS equal to this one. So this is actually equal to your AI. Okay. All right. So in every time you will find your gain, it must be in decibel. Okay, decibel. Decibel is a unit. Okay, you have to convert it into decibel. So how you convert it into decibel is equal to 20 log AV. So whatever AV value or AI value you got, okay, you get the value, you have to 20 log the value, and finally you get in decibel. Okay, decibel. All right, so these are the important equation. So I'm not suggest you to memorize this formula. Okay, because what? Because you can actually derive it. Okay, it is simple. Just use voltage divider rule at the input. Voltage divider, as for this case, just apply voltage divider rule at the input and voltage divider rule at the output, and you rearrange everything, the equation, okay, by knowing what is your objective. Okay, for example, your objective is to get V out over V in, therefore you apply voltage divider rule at the output here. Okay, and then your objective is to get AVS. So AVS equal to V out over V in times V in over VS. It's like cancel out, but it's not. Okay, V out over V in, you already get this. Okay, so how to get V in over VS? Again, apply voltage divider rule at the input. Okay, you rearrange the equation, you get finally your AVS equal to AVZ in over Z in plus RS. Same goes to this one, the current. Okay, so you apply not voltage divider, now you apply current divider rule. Okay, current divider rule and also KVL at output loop. Okay, so your objective is to get I out over I in. Okay, so therefore you apply KVL here in order to get AIS. Okay, current gain referring to the source, you apply current divider rule here. Okay, so now you already have I out over I in, which is equal to the AI. Now, what is I in over IS? This portion. So you just derive from current divider rule at the input. That's it. That's how you do it. Don't memorize this. Okay, this is too much formula. Okay, you just derive it. All right. So, all right, so let's have the first example. Okay, I want everybody try this example now. Okay, find AV, AVS, and also V in and VS if VL equal to 4.11 VAC. All right, find this first. Okay, AV and AVS first. So can anyone, can all of you try now? Hello?
Yes, madam.
All right, okay,
Yes.
everybody try.
Fine.
Okay, get ready with your calculator with you. I give you about 5 minutes. Okay.
Oh, madam, what is the value of VS? Oh,
No, no
oh,
VS. You can cancel out the VS.
oh, okay, okay.
Okay. So V out is actually equal to what? V out is actually equal to what? V out is actually here, VL. Okay, this is V out. Okay, they put it this VL. This is actually your V out as well. Okay, so okay, this is your V out. Okay, same thing, VL or V out. Oh, search. So finish. Let me charge my laptop first. All right. Okay. So all of you get the answer? Finish? Hello?
Oh, yeah.
Dah. I mean,
Yes.
get all the answer? Manage to get all the answer? Do you want me to show the solution? Or all of you got the answer?
Oh, no. So the solution, madam.
Okay. All right. So let's do it. Okay. Give me a second. Need to drink some water. Okay. Okay. Now let's do it. Okay. So this is the question. So given, what are you seeing in the screen now? Sorry, guys.
A blank slide.
A blank slide.
Yes.
Yeah. Give me 1 second. Sorry. Now can you see the question?
Yeah.
Yes.
Okay, so determine the values of AV, AVA, AVS, VIN, blah, blah, whatever. Okay, so this is the circuit given. Okay, all right, so your objective is to, okay, let's do it. Okay, so I might have to draw again the, oh, no need, no need, no need. I want to copy. Okay, just copy here. Okay. Okay, so this is the circuit. Hey, what is that? Sorry, sorry. Oh, alah. Okay, sorry. So here is the circuit. Okay, great. Okay, like this. All right. So you want AV. Okay, so this is solution. Okay, you want AV. Okay, so AV is, you know, V out over V in. Okay, so this question, they wrote VL, but it is actually V out. Okay, V out. It's actually voltage at the load resistor. When voltage at load resistor, it is actually equal to the V out lah. You all know. Okay. Okay, so now, I said apply apply a voltage divider rule. Where to apply the voltage divider rule is at this output. Okay, at the output. Okay. Okay, so from here, when I say VDR is it is a voltage divider rule. Okay, so from here you can get your V out. Okay, sometimes I write V out, VO, so V out lah. Okay, so V out. What is V out here? So you apply voltage divider rule. You know that V out is equal to RL over RL plus Z out times the voltage, all value of the voltage given here is AVOC V in. So this is the formula. So it is actually AVOC, another value given, like I say, it is a gain factor value given 400. So from here you can calculate you can actually rearrange the formula. So your objective is to get AV, which is V out over V in. So you rearrange here, so you will get your V out over V in is actually equal to the RL over RL plus Z out times AVOC. Doesn't this equal to AV? Yes, it is. Okay, so RL here, if you calculate RL over RL plus Z out, blah, blah, whatever the value, blah, blah, blah. So 3K plus 300 and AVOC is 400. Okay, therefore you will get the value here. The answer is correct, right? 363.6. So this is the answer. Okay, 363.6. All right. So up to here, all of you okay? Understood? Understand?
Yes, madam.
All right. Okay.
Yes,
So
Yes.
also.
great. Okay, great. Okay, then I proceed to AVS. Okay. So AVS, okay, AVS, Dr. Izaila said it is V out over V in and V in over S. Okay, over S. All right. So this is actually the same thing here. I said, okay, the same thing here. Same thing here. This one. Okay, AVS equal to V out over V in times V in over VS. Why I want to use this? Because I already have this value, AV. So it's just a matter of to manipulate other equation. Okay, so this one I have, which is AV. Now the problem is V in over VS. Where to get this V in over VS? From the input here, also you apply voltage divider rule. Okay, so if you apply voltage divider rule at the input here, you will get your V in is equal to Z in over Z in plus RS times Vs. Okay, and here you will get, you manipulate the equation, you get V in over Vs equal to Z in over Z in plus Rs. Okay, so now do you have this portion now? This portion? Yes, you already have that this portion. So this portion it is actually equals to, so this one V out over V in is AV. So V in over VS is actually Z in over Z in plus RS. So you can calculate the value here, 363.6 times Z in blah blah ni 800 plus 50 and you will get the answer, final answer here. Is it the same answer here, students? 342? Is it the same answer?
Yes.
That betul tak?
Yes.
I didn't calculate, but I hope it's correct. Okay, so that's how you get. Okay, that's how you get. So AV and AVS. All right. So this part clear. Okay. All right. So let's take a look on the next part, which is they ask you to find V in and also they ask you to find VS while they give you the value of VL, or this is actually your V out. Okay, equal to the 4.11 VAC. All right, so your answer will be in terms of VAC. All right, okay, let's try here. I'll use different color to differentiate. But this is too small. Okay, like this. Okay, so they said find V in and also find V out. So V in and VS. So you given that V out, okay, V out is equal to 4.11 VAC. Okay, so they want V in first. Okay, let's take a look on the V in. Okay, you already know that V out over V in. Oh, too frustrating. It's okay. Another slide then. Okay, one more slide here. Okay. So V out, which is equal to the VL given 4.11 VAC. Okay, you know that V out over V in is equal to AV. Okay, AV you have calculated it. So now you want V in. The question want V in, VI equal to V out over AV. So V out here given 4.11 VAC. Okay, AV, you have calculated the value. AV is equal to, where is AV? 363.63. 63.6. So V in is equal to, I'm not sure whether this is correct or not, but I hope the calculation is correct. Have you all tried? Can you all divide this? 4.11 VAC over 363. So it's actually you are dividing 4.11 over 363.6. Is it 11.3 milli, students? Yes,
Yes.
Sabrina says. Okay, great. Okay.
Yes.
All right, great. Okay, so now you have done for the VI part. Okay, now they want you to calculate VS. Okay, VS. So of course, VS from what? So you have V out over VS equal to the AVS. Okay, why we use AVS? Because you have calculated the value for AVS. Okay, so now to get VS, it is actually equal to V out over AVS. It is equal to 4.11 VAC over AVS just now 342.342.2. How much here? 4.11 over 342.2. 12 milli. Is it correct? Is it correct?
Yes.
Yes.
Did you all try to calculate? Plug in your calculator?
Yes, yes.
Yes,
Yes,
great.
madam.
Good. Okay. So, is it the solution clear? Answering all your confusion just now?
Yeah, yes.
All right,
Yes.
great. Very good. Okay. So, can we have a break? 5-minute break? And then we continue. Okay?
Okay, madam.
All right, great. Okay. 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 So I have actually uh, posted what topic will be covered for test 1. So let me show you here. This is your course information. Well, take 5. Is it okay if I'm sharing this? You don't have to think, just listen. Okay? All right. So for test 1, so test 1 will be on 23rd of April, which is about 2 weeks from now or 3 weeks. Now is 7th, about 2 weeks, about 16 days. Okay, so on Friday, 9 a.m. So the topic cover, so for chapter 1 overview, this one will not be covered in the test 1. Okay, no. Okay, what topic that will be covered is diode. Chapter 2 diode. So chapter 2 diode, we have seen a lot of question. Okay, example, past test that I have put in the tutorial. So that kind of question, okay, for the PN junction. Okay, so please study that one. Okay, I also have uploaded the complete solution, okay, for the tutorial. So you may have to check that, okay, study again. And also the Zener diode, okay, and also the basic power supply. So this one so question will be PN junction, okay, and also DC load line analysis and the rectifier circuit, okay, rectifier circuit either one, bridge or center type. Okay, and then it has a question Zener diode as voltage regulator. So today I will upload. So we have not yet have tutorial question for basic power supply. So today I will upload some set of question from the past test and some other question for the basic power supply. Okay, and also capacitor filter and also Zener diode. So please do it during the weekend, and we will discuss on Monday class. Okay, Monday class, the second hour period. Okay, all right. I will upload later. We will discuss Monday or Wednesday. Wednesday. We will discuss on Wednesday. Okay, Wednesday. So you have more time during the weekend up to Wednesday. All right. Okay, so we have done the, are we finished? 5-minute break? Oh, attendance. Yeah, I'll show the attendance. Wait. Okay. 2 minutes. No. 1 minute for the attendance. All right. Done? Yes. Okay. So let's continue. So this one is for the voltage gain. Okay, for the voltage gain doesn't involve anything with current. Okay, so for example 2, so it has a current. Okay, so given that, so what are the difference between this amplifier model and this amplifier model? So in the previous question, the amplifier model, it has RL here. Therefore, you when you want to find your V out, you use the concept of voltage divider rule. However, here the output part is open circuit. Okay, open circuit, no RL. So this make these two amplifier model differentiate these two amplifier model. This has RL, this one has no RL. And therefore, the V out here is equal to the AVOC V in. Why?
There's no current flowing.
Yeah, correct. Because this is no open circuit, okay? So therefore, this Z out is 0, short circuit. And V out here will be equal to the AVOC V in. So that's why V out equal to AVOC V in. Now, can you all try this first, okay? This example. Okay, can you all try first?
Okay, ma'am.
Yes, madam.
All right. Okay. Great. No one answering me. This is the sad thing about online. Can't see your face. If it's a face-to-face class, I can see your face, right? Okay. So you try first. I believe that one is the correct answer. I think so.
Yes.
Yeah. Great. You have tried. Yeah. Great. Thank you. Let's wait a couple of minutes for other
But I
to.
don't sure it's correct or not.
If at least like about two or three people of you getting the same the exact same answer be correct. Okay, so you do it first. Let's see. Anyone of you staying in Sabah or Sarawak? Anyone? Oh, all of you are in Semenanjung.
Me.
Ah,
I'm Sarawak.
oh, Alex Sarawak. I see.
Ini
So now you
Sabahan.
got Sabahan as well. I see. Okay. So you're all in Sabah Sarawak lah. Anyone coming back to UTM when the semester starts the other past 3 weeks? No. Oh, this is your second semester, right? So no one is in UTM right now. No one. I see. Okay. Oh, I'm in UTM. Anas. Ah, I see. Okay. All right, finish. Try this example. Did you all, if all of you get the answer, so the same answer, so I don't have to show the solution. If not, then of course I'll show the solution. Give you all 1 minute more.
1 minute more, madam.
All right. Okay, 1 minute more. Okay. Okay. All right. Okay. That's it. So all of you get the same answer? You want me to show, or you got the same answer like in the slide? Tell me. So when Chuan said they get he got the same answer. So how about the rest?
Get the same answer.
Great. Okay. Other students? If you lazy to talk, maybe you can type in the chat box. You got different. So yeah, someone get different. Some of you said the same. Bezin said good different. Okay. So which one different? Which part different? B part. All right. Okay. Okay. C part. Okay. It's okay. Let me show you. Okay. So for this one, I think I have space here. Okay, so I will just write it here. Okay, so V in over V out is equal to, since that V out, okay, from here, you know that V out is equal to AVOC V in. Okay, therefore V out over V in, okay, is equal to the AVOC. All right. So V out is also given. Okay, in order to get V in, of course, you rearrange this. You will get V in is equal to V out over AVOC. Okay, so this one, AV out given 7.68. Okay, AVOC also given 320. So 0.68 over 320, you will get here about, I think same, 24 millivolt. Correct, right? Yes. Okay. So I in, all right. Is it correct, student? Yes. Okay, great.
Yes,
Okay.
madam.
Okay. So I in, okay, where to get I in? Okay, now you have to apply, okay, so in the input circuit, okay, so you have here V in, okay, V in. Okay, and also Z in. So you can actually apply KVL here. Okay, KVL here. So in here, the KVL will be, it is actually equal to, sorry, you can actually apply, is RS given? Yes, RS given. So you can actually apply here as well. In this case, we don't know Z in. Therefore, we can't apply the first loop like here. Okay, but we have RS, okay, and also we have VS. Okay, now we already calculated the V in, so you can actually get the I in. So this I in is actually the same I in here, so it is in the same loop. Okay, series. Okay, therefore you apply KVL. Okay, you will get your I in. So negative VS plus I in RS plus V in equal to 0. Therefore, your I in is equal to VS minus V in, okay, over RS. So VS is given 40 millivolt. Okay, V in is you got the value 24 milli over RS is 1.2 K. Allah. Mm. 1.2K. Okay, so you get, seriously, okay, how much here? Is it the same answer?
Same.
Yes, same.
Yes,
All right,
same.
great. Okay, third. Oh, can I get angry with my tablet? Oh, Does it matter? Ish. Okay. Okay, 13.33 microampere. Okay, so this is the answer for I in. Okay, so is it okay?
Yeah,
Yeah.
All
Yes,
right.
madam.
No, not time to buy a new one. This is new. New. I bought it new during the first online class. This is not because of the, I think it's something to do with my PowerPoint. Okay, when I write at this area, I can't write. This area I can. I don't know why. Whatever. Okay. Okay. So Zac in. Okay, Zac in. Okay. So how to find Zac in? So now you have your I in, which is 13.33 microampere. So Z in, you know that V in is equal to, I have to write here. Okay, is it okay? Find it yourself. Okay, Z in, I in. So because V in is voltage across Z in, therefore we know that I in, Z in. In order to get Z in, it is equal to V in over I in. So V in, give, where is V in? Oh yeah, V in 24 milli. I in is 13.33 micro. So can someone help me to calculate here? How much is that in? Is it correct? 1.8K?
yes,
Yes,
madam.
madam, correct.
Okay, great. Okay, so great. Okay, all right. So Zian said, now I get it. All right, great. Okay, so AVS, do you know how to get AVS? So since I have started calculated it, okay, so AVS is equal to what?
The output over the
Uh-huh.
input.
Yes, V out over V input. Okay. All right, so V input and times V input over VS, right? Okay, so it's like you cancel out, but you know, you don't actually, okay? So AVS is equal to this one is AV, okay? AV, okay? This is AV, but since you don't have RL, therefore your AV is equal to what? What is AV here?
Then we have V output and VS. It's just
Ah,
you.
is it the same answer there? Over there, 192? The
Yes.
same answer? Great.
Yes.
Okay. So you can also you can straight away calculate V out over VS because you have all the value just now. So V out is 7.68. 0.68. VS 40 milli. 40 milli, which is 192. Okay, but you can actually do like this also. Okay, so V out over V in is equal to the AV, but now there is no RL. Okay, therefore your AV is equal to AVOC, okay, times V in over RS. So you can V in over VS, you can actually do voltage divider rule at the input. It is equal to the Z in over Z in plus RS. Let's say that you don't have all this value, you can solve using this as well. Okay, you should get the same answer. All right. How about you try? Did you get the same answer? Can someone calculate for me? AVOC times Z in over Z in plus RS. Can someone calculate for me?
Exactly the same.
Yes, Sabrina said exactly the same. You say exactly the same. Okay, great. So same answer. So you have two ways to solve it. Okay. Yay. So Actually, that's it for today's slide. But we have how many minutes? 20 minutes. Okay. 20 minutes.
Doctor,
Yeah.
what about the one dB? The calculate in dB. Did,
Okay.
did the question mention?
Yeah, question mentioned. Alex, so question mentioned if they want you in dB, they say the question will be like this. So they write it in dB. So you have to convert it into dB. For this case, no dB. But after this, when we go part 3, they ask you to calculate dB. Then how you convert in dB, just like this. You have 20 log times 192, for example. Okay, all right.
Okay, thank you, Doctor.
Okay, welcome. Okay, yay, we have done this, but since we have about 20 minutes, okay, I need to continue, not continue lah, I mean to introduce to you, okay, at least introduce a bit of it, okay? Is that okay? Okay. All right, so for part 2, okay, part 2, just introduction, okay? All right, so BJT, so this one for part 2, do I need to record another one or no? No, okay, doesn't matter. Okay, so for part 2, I just want to introduce. So BJT as an amplifier. So it has 3 types of common emitter, common base, and common collector. Again, same like diode, we have to analyze it mathematical method and also graphical method. Same for BJT as well, we have to solve it using graphical and mathematical. Okay, for for BJT, it has 3 configuration of circuit. Okay, just means 3 types of circuit for BJT. One is fixed bias. The second one is emitter stabilized bias. The third one is voltage divider. I'm going to show you all type of circuit and also the example for all type. Okay. Okay. So in here, now now we want, actually this part 2 is to solve the DC analysis circuit for the BJT. Okay, so DC biasing here involved with the to find the base current, collector current, and collector to emitter voltage. Okay, and also the bias circuit design that the value IB and beta vary inversely, okay, and partially offset the effect that the increased beta. This one is has to do with the equation, okay, where you know that this equation beta is equal to IC over IB. Okay, when IB increase, beta will decrease. Okay, so BJT need to operate in active region. Okay, see it has many regions: saturation region, cut-off region. So active region, BJT will can be applied as an amplifier. Okay, for cut-off and saturation, it will be applied as switches. Okay, so this is how it looks. Okay, the real circuit of BJT. Okay, so this is one of the type, which is voltage divider type. Okay, for this case, in order, now for part 2, okay, you are solving the DC analysis. Okay, for part 3, you're going to solve for AC analysis. So for DC analysis, what happened to all the capacitor? So all capacitor, we open circuit. Okay, the equivalent circuit will be like that. But then how to solve it? Where to get I, C, IB, and so on. So that's here. This is the objective of part 2. Okay, from this circuit, from this circuit, now you want to simplify the circuit to get all the parameter of current, IC, IB, and IE. All right. So biasing means that the same like diode, it must be at Q point, okay, at active region. Here also has Q point at active region. Okay. So now you are you want to find the Q point. Okay. For diode, you find Q point for IDQ, VDQ. For BJT also, you want to find the Q point, the IBQ and ICQ and IEQ. Okay, so like I said, type of biasing has 3 types. Okay, today I'll show you one type only, fixed bias circuit. Okay, so this is to recall the information. Okay, these are the important information. These are only equation that you need to memorize lah. Memorize, okay? Not memorize. If you understand it is actually no need. But as you go on with a lot of exercise, you will automatically memorize this all. Okay. So this is how it looks for the fixed bias circuit. So like I said, the emitter is ground. Okay, you have base here. Okay, you have base. It has resistor RB, and you have voltage supply VCC, and also you have VCE voltage. Okay, what happened to all these two capacitors, C in and C1 and C2? In DC analysis circuit, it will be open. So here are the steps to solve. Okay, it look panjang, but I'll show you step by step. Okay, first remove the capacitor C1 and C2. Okay, and it will be open circuit. Okay, first remove here. So you remove capacitor C1 and C2, the circuit will be simplified like this. All right. So second step is the DC voltage supply can be separated into two. So this one separated into two. Okay, at the input here and at the output. Okay, that doesn't matter. I'll show you the step by step. So it is separated into two. So now you're solving the input part. This is the KVL. Okay, this is the output part. This is the KVL. Okay. And third part is to apply KVL to all the circuit. Okay, this is input. Okay, and this is output. Okay, for better understanding, let's do it. The example one. Okay, I'll show step by step for the example one. Okay, so this is how you do it. Okay. Okay, so this is your circuit. Okay, this is the circuit given. So given this circuit with all the resistor value and the voltage value and so on. So first thing first is to remove the capacitor. Okay, you remove the capacitor, you will get, wait, I need to copy first this circuit. All right, so that is the circuit. Okay, so that's how you do it. So first step, they say that first step is to open capacitor. Okay, open capacitor. So you redraw the circuit when it open capacitor. So it will be look like this. So you have resistor here, and then you have your BJT. You have your resistor here. This is your VCC. This is your RB. Okay, so this is your RC and this is ground. Okay, so base, collector, emitter. All right, so here I said that again. So at base to emitter, you have voltage here, which is VBE. And VBE is always approximately equal to 0.7 volt. Okay. All right. So second step is to separate between input and output. Okay. All right. So this is your circuit. So the second step, okay, second step is separate input and output. Is that okay? Input and output. Okay. So third step is to solve the when you separate input and output, and then third step is to solve the KVL lah. So now at input loop. So let's take a look at input loop. Okay. At input loop. Okay. So at input loop, okay, remember, draw your transistor first. Okay, you have here base, emitter. Okay, so this is your input. Okay, this is your input. Okay, so let's start from the base. Okay, from the base. Okay, so at the base here, you have what? You have RB. Okay, RB. Okay, so you have RB. Okay, now RB is connected another point to the plus VCC. Okay, plus VCC. Okay, so your ammeter now is to the ground, Okay, so where does this negative VCC go? Of course, negative VCC will always go to the ground. Alright. Okay, so this is your input loop. Okay, put all the parameters. So you have voltage junction VBE here. Alright, and also you have at the input of the base, you have IB here. Okay, so this is your IB. All right, so you're getting your IV there. Okay, so look at here, all the information needed is VBE equal to 0.7 volts and also IC equal to beta IB. So I want to copy this, okay, since this is first time you see this equation. So I will put later on, you will, I believe you all will memorize all this important formula when you do a lot of exercise. So I just put it here. Okay. All right. So now let's apply KVL at the input loop. Okay. KVL at the input loop. Why? Because the question asks you to find IBQ and ICQ. All right. IBQ and ICQ. So let's take a look here. So we apply KVL at this input loop. So your KVL at input loop. Okay, so you will get that. So VCC, how much the VCC given? Which is 12 volt. Okay, RB is 240K. Okay, VBE 0.7. All right, so apply KVL. So apply KVL, you will get, let's start from the VCC, you will have negative 12, okay, plus 240K IB plus, don't forget your voltage junction there, which is VBE plus 0.7 equal to 0. So this is your KVL at input loop for BJT. Okay, so now you are calculating your IB here. So 12 minus 0.7 over 240K. So you will get the value. Can someone calculate for me?
.1 microampere.
All right, 47.1 microampere. That's it. Now you have got your IB. Okay, IB or IBQ the same lah, because they put Q because they said this, they consider this circuit at active region. So this is your value. IB is equal to 47.1 microampere. So you have got that IBQ. Okay, IB or IBQ same lah. Okay, so how to get IC now? Okay, IC. Okay, IC. How to get IC? Again, so since you have not familiar yet with BJT, so in order to get IC, you will use this formula, okay, which is equal to the beta IB. Okay, beta usually given in this question, it is 50, okay, 50 times 47.1 micro. So how much here? Oh, okay, how much here?
2.355 milli.
Okay, 2.35 milliampere.
55.
55. 55. Yalah. Alright. That's it. So now you get your ICQ done. Okay, so this is, you are actually solving the input loop. Okay, the rest, so this one here, you need to solve the output loop. Okay, before I proceed the output loop, do you have any question for the input loop? Student?
No, madam.
No.
Madam,
All
how do
right.
we get the value of beta?
Beta. Beta
Yeah.
here. Beta is here.
Oh,
Given.
okay.
All right. Okay. All right. Great. Okay. If no question, I proceed to the output loop. Okay. So this is for the input loop. So now let me show you the output loop. Okay. So output loop is here. 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 You are solving this loop. Okay. The output part. Okay. So this one is input part. So at the output part, okay, at output loop, okay, output loop. Okay, so now output loop, you have to draw your BJT again. Okay, your BJT again. Okay, input part doesn't matter. Now you are considering the output part. Okay, so you have collector here and emitter here. So let's take a look one by one. So at collector here, you have RC. Okay, you have RC. Okay, and then RC, after RC, the other node of RC, you connected to the VC. Okay, VC. So you have positive VC. Okay, positive minus VCC. So you emitter is to the ground. Okay, ground. Okay, this is your emitter to the ground. And where does the negative? Always go to the ground. So this is your equivalent circuit. So RC is equal to the 2.2K and VCC equal to the 12 volt. All right. So in input loop, you have voltage junction here, which is VBE. At output loop, you also have voltage junction here, which is VCE. Okay. Here, VBE, voltage junction, is always 0.7, like most of the time 0.7 volt because it made of silicon. Okay. Now, VCE is your objective. Now you need to find what is your VCE. Okay. Again, you apply KVL at your output loop. Okay. Apply KVL at output loop. You will get. Okay, so your input loop, it is clockwise like this because I said that current is always going out from plus and go back, going out from plus and go back to negative. Okay, so does this one, going out from plus and go back to negative. So that's why the current direction, the loop is like that. Okay, so your KVL will be negative 12. Okay, don't forget in input loop, you have IB. Okay, at output loop, okay, what are the current involved here? Which is IC. Okay, so this is your BJT. You have IB, you have collector, emitter, and base. So this is your IB. So current involved here is IC, and this is IE. So current IC going into the collector. Therefore, current IC is in this direction. So this is your direction for IC. Okay, so you have negative 12 and then plus 2.2K IC plus VCE equal to 0. Okay. Now you already have your IC value. Can you get your VCE from here? Can. So therefore 12 minus 2.2K IC is 2.355 milli. So here, how much did you get for this value? 12 minus 2.2K times 2.355 milli?
6.819.
All right, great. 6.8, oh, sorry, 82 volt. Okay, so this is at Q point VCE Q. Okay, now you are getting the VCE Q. So up to here, do you all have any question?
Thank you, Doctor.
Clear, very clear?
Yes.
All right, great. Okay, great. Okay, so now the question asks you to find VB and VC. All right, VB. Okay, so these are the tips. Okay, so to find, so VBE, okay, VBE, okay, is equal to this VB minus VE. All right, so VCE is equal to VC minus VE. Okay, in order to get your VB here, therefore it is equal to VBE plus VE. Now, what is VE value? What is VE? Look at the ammeter here. Look at the ammeter. It is grounded. Therefore, VE equal to what? 0 volt.
0.
Okay, you only said it is 0 volt. It is correct, 0 volt. Therefore, VB is equal to 0.7 volt. Okay, so where is actually VB? So VB from the input loop is from this node. Okay, if I highlight here, so from this node, okay, to the ground. Okay, what can you see from the base node to the ground? So you are actually only see VBE. There is no RE here. Okay, if there is RE, therefore there will be VE value. But now emitter to the ground, therefore from base to ground is just VBE. That's why if you use this kind of concept also doesn't matter. We get the same answer. Therefore VB equal to the VBE 0.7 volt. Okay, now VCE equal to the VC minus VE. Okay, in order to get VC, therefore, oh sorry. Okay, in order to get VC is equal to the VCE plus VE. Okay, VE 0 equal to VCE 6.82 volt. Okay, where does the VC, where is actually your VC? So it is actually from this node, okay, from this node to the ground, okay, to the ground. Okay, to the ground. Yeah. So what can you see from the collector to the ground? You can only see VCE only. So that's why VCE is equal to the VC. So you get this value. So now you have gotten the VB and VC. Okay. How about VBC, student? How about VBC? Okay. If you understand these two,
B minus BC.
correct, VB minus VC. So it is actually 0.7 minus 6.82. It is negative value. Can someone calculate for me?
6.12.
Negative value?
Negative 6.12.
Negative 6.12 volt. Okay, that's it. This one, VBC. Yes, so that's how you solve the BJT part, okay, the DC analysis circuit. Okay, so do you have any question for that? I think it's quite easy lah to me. Just KVL where you apply the input loop and the output loop. Okay, so do you have any questions, student? Any question regarding this?
So the capacitor there is for filtering or for what?
The capacitor there is for filtering, but it will be used during AC analysis. So basically, this circuit is solving two parts, okay, the DC part and also the AC part. For DC part, every time we will open circuit the capacitor. But for DC part, we will consider the capacitor later, not in this part, later in part 3 or part 4. Okay?
Okay. Okay now.
All right. Welcome. Any more question? No question. All right. Okay, great. If there is no question, so that's it for today. Okay, I will upload a question from this part. Okay, so that it will be exercise and we'll do past year for the test lah, test 1. Okay, I will upload the question later. Okay, later today. All right, all. That's all for today. Are you all sleeping?
No.
All?
Yes,
No,
Doctor.
okay.
No,
All right. Okay. All right. That's all for
Thank you,
today.
Dr.
Welcome. Okay.
Thank you,
Take care
madam.
all. Welcome.
Doctor, can you
Welcome.
share
So,
the QR code, please, for
yeah.
attendance?
Yeah. All right, all. See you all next week. Can you see?
No, Doctor.
No. All right. One more time. Wait. All right. Can you see?
Dr.
Okay.
Yes, Doctor.
All right. Okay. Okay, all.
Thank you, Dr.
Welcome. Okay.
Thank you, Doctor.
Welcome. All right.
Doctor, and have a nice day.
All right. You too. Have a nice day. Take care. Bye.